Transversal. The next topic in the session is about discussion of transversal. What is transversal? Let's see the definition and its property in more brief in the session. Transversal. What is transversal? As we see, imagine I have two lines L1 and a line L2. Any line which intersects L1 and L2 at two distinct points is called transversal. Say for example, I take a line which cuts the line L1 at P and the line L2 at Q, then this line is called the transversal. Transversal is a line which cuts two or more than two lines at two distinct points P and Q. This is the transversal for these two lines. Is how we understand the transversal. Imagine I have L1, L2, L3, L4, L5 and L6. There are 6 lines out here, and then there's a line which cuts this at A1, A2 and cuts L3 at A3 and cuts L4 at A4, L5 at A5. Then this line which cuts each of the lines L1, L2, L3, etc. till L6 at different 6 distinct points A1, A2, A3, A4, A5 and A6 also is called a transversal. A transversal does not have a restriction on two lines, but there can be any number of lines through which the line must cut at distinct points. So this is also an example of a transversal. As how we understand the transversal property of the condition. Is how we understand this. Imagine I have a line L1 and line L2, and here I have a line which cuts L1 at P but does not cut the other line. Therefore, this cannot be a transversal for L1 and L2. Is not a transversal for L1 and L2. Is how we understand the transversal property in mathematical understanding. Transversal is a line which cuts more than two lines at two distinct points or at all distinct points. Is how we understand transversal in geometry. Parallel lines. As we have discussed about parallel lines in many instances while coming across in theorems, axioms, solving problems, let's see in brief about what are parallel lines and what are the mathematical properties related with parallel lines. Parallel lines and its discussion. What are parallel lines? Imagine we have a railway track in which the two rails are exactly at equal distances. There is no possibility that the two rails meet at the railway track. So the railway track can be taken as an example of a parallel lines which are separated by this grids out here. The two rails, this is rail 1 and this is rail 2, and the two rails never meet, but they go on and on and on, but they never try to meet is how we understand the two parallel lines. So mathematically, when I connect these two rails with the railway track, I clearly understand that this is an example of lines which are parallel. Since these two never meet, they are parallel. So mathematically, I define the parallel lines to be those lines which never meet. They always go on and on till infinity, but they never meet, is how we understand the parallel lines. Parallel lines and its properties to be continued further. Now let's take two parallel lines to understand the further properties related. Imagine I have two parallel lines L1 and L2. So these two lines are parallel because they go on and on, but they never meet. And interestingly, there will be equal distance at every pair taken on the two lines. They are at equal distances everywhere. And let me say there's a transversal which cuts the lines L1 and L2 at these two distinct points. These 2 points of intersections. Now, as we can see that the transversal, when it cuts both L1 and L2, makes 4 angles with L1. 1, 2, 3, 4. This transversal, when it cuts line L1, makes 4 angles, 1, 2, 3, 4 with this, and makes the other 4 angles with the line L2 out here. So totally there are 8 angles formed by the two lines which the transversal cuts with, is how we connect the properties. A transversal cutting the lines L1 and L2 which are parallel. L1, L2 are parallel as they never meet. Because they never meet, they are parallel. And let's see how are the properties related with the parallel lines with the transversal. So let's see the interior angles in the parallel lines. To start with, the first property related with interior angles. So parallel lines connected with interior angles. Is what we are going to discuss in the session. So let me take two parallel lines. L1 and L2. And let me have a transversal which cuts the lines L1 and L2, thus making 4 angles here. 1, 2, 3, 4, 5, 6, 7, 8. Now, out of these 8 angles, we call the interior angles as those angles which are in the interior region of the parallel lines. So clearly I can see that this and this are in the interior region of the parallel lines, where 1, 2, 7 and 8 are said to be outside, that is in the exterior region. So interior angles are the angles in the interior region. So let's see what are the angles in the interior region. Angle 3, angle 4, angle 5, angle 6 are said to be the angles in the interior region. and therefore these angles which are in the interior region of the parallel lines are said to be interior angles. Interior angles in the parallel lines is angle 3, angle 4, angle 5 and angle 6.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.